Hello and welcome again to Chemistry with Mr. Olson. Today we're doing heat worksheet question 28, and we have at our disposal we have the table of specific heat capacities, and well, let's read the question. You start with 77 grams of cold water at 25 degrees C. You add a hot piece of iron at 97 degrees C. So we put the two of them together. If the temperature of iron and water both end up being 36 degrees C, what's the mass of the iron? Okay, at the heart of this problem is the observation that the Q of the water will gain heat, so it's going to be a positive number. It is equal and opposite to the Q of the iron. So there's the heat energy gained by the water is equal and opposite to the heat energy gained by the iron. Q equals mc delta T. So let's expand this equation. Mass of the water, C of the water, delta T of the water equals minus 1 times mass of the iron, C of the iron, delta T of the iron. There we go. So we've got the 6 variables, and presumably we know everything but the mass of the iron. The question asks, what's the mass of the iron? So let's solve for the mass of the iron. In other words, off to the right, I'm going to switch colors just to keep things clear. The mass of the iron equals, well, we're going to have a minus in there, minus MWCW delta TW, minus, and mass of the water, C of the water, delta T of the water. And we have to divide by, to get M of the iron by itself, we have to divide by C delta T of the iron. So divided by C Fe delta T Fe. Now, that's our algebra, and all we have to do is, we got formula equals, since we've got the variable we're searching for here, the mass of the iron equals this, equals, let's substitute. So what's the mass of the water? Well, we've got 77 grams of water. So we say 77 grams of water, and specific heat of water. Now, the specific heat of water, looking in our table, 4.184 joules per grams degrees C. Now, you might think, well, we could use calories too, but notice we're going to be using for iron its value in joules per gram degree C, so it's nice if the joules cancel. So we're going to definitely use 4.184, and I'm going to do joules per gram degree C like this because the specific heat on the bottom will have similar units and they will just cancel. Delta T of the water. Well, to substitute that, we've got to do a little calculation over here. Let's do delta T of the water equals, well, that's T final, T final minus T initial. What's the final temperature of the water? 36 degrees C. Minus the initial temperature of the water, well, it was cooler, 25 degrees C equals 11 degrees C. So there is our delta T for the water, 11 degrees C. Over C of iron, the specific heat of iron from the table, 0.45 joules per gram degrees C. So 0.45 joules per gram degrees C. So you see those two units will cancel, sets of units. And the delta T of the iron. Let's switch colors. Delta T of the iron equals its T final minus its T initial equals final temperature of the iron, of course, 36 degrees C. But the initial temperature of the iron was hot, 97 degrees C equals, doing the math, that comes out to a negative number, negative 61 degrees C. Negative makes sense because the iron got cooler. It lost some heat. So that is our delta T for the iron. So we substitute in, I like to write negative numbers in parentheses to make it clear we are multiplying. Let's cancel some units. Grams, grams doesn't cancel, and that's good because we're seeking grams. But joules per gram degrees C, big cancellation, and also the degrees C over the degrees C. And notice we're left with grams, which is good because we're calculating mass. So we will do a continuation equal sign here, and the math comes out to 130 grams. If we check our answer, I think that matches the answer. I really should check. Let's see. An answer on the front side, 130 grams. Yay, 2 sig figs. All right, so that is our calculation. I hope it's helpful, and have a good evening. Ta-ta.